Guys, today I'm going to talk about putting a Windows Server VM in a container. Now, this idea might sound absolutely nuts, and when I first thought about it, I thought it was pretty crazy too. So before you click away from this video or you pick up a stone to throw me, hear me out for just a second. If you've been following this channel, you've noticed I've got this thing for containerizing old technology. I containerized DOSBox, which allows you to play old DOS games in a container and have the results stream back to a browser. I did the same thing with RetroArch, and that particular container allowed me to play things like SNES and Sega and NES and Atari games in a browser. And I also did the same thing for Windows 98, where I took Windows 98 and I put the Windows 98 operating system in a container and then had the results come back to a browser. I could run everything just like I was running it on my desktop, except it's running on a remote server. And I was going to use that as a springboard to go ahead and do the same thing for Windows XP. And at some point, I'm going to do a video on Windows XP. But as I was working on the Windows XP implementation, I thought about, I wonder if I could do this for Windows Server. So I set aside the Windows XP implementation for a little while to focus on running the Windows Server implementation. And I wanted to approach this more around the purpose of building something that you could actually use to host an application rather than just something for nostalgia like the other implementations that I've been working on. So it turns out not only is it possible, it's really not even that bad. So the implementation for running Windows Server, I wanted to optimize it for the best performance possible rather than just the nostalgia effect of having the Windows chime play and the ability to interact with the desktop. I wanted to actually be able to put an application in this and have it be an application that would be running as if it was running on an actual VM in the way that it would run on a VM. So performance was kind of the key driver here. So let's go ahead and look at the justification for why you might even consider this as a possibility. And then we'll look at the technical implementation of this, where I'll show you kind of the architecture of how it all works that's in keeping with the way that you typically run a container. And then I'll show you an implementation using Windows Server 2008 with IIS on it. And I'll talk about how you can use that as a legitimate platform for running applications. So here's the scenario that I had in mind for this, where we have this old app that's sitting on a server. Maybe it's a server that's a physical server in a server closet somewhere, or maybe it's an old virtual machine, but it's years overdue for an upgrade and you need to get it into the cloud somehow. So there's 4 canonical approaches and there's 4 more edge cases. So the VM in a container is certainly an edge case, but the 4 canonical ones are probably going to be most obvious to you. And the first one is going to be platform as a service. Now, platform as a service is something like Azure App Services. In that case, you could easily run most modern software in that, but in some cases you can run some old apps in there as well. I've run some apps that were written 20 years ago in .NET 2 in platform as a service on Azure with great success before, and without changing any code or anything like that. So it is possible, but it's not always possible. So if it's not possible to run it in a platform as a service, you could go to a virtual machine. Now, a virtual machine in the cloud is typically going to require a more modern version of Windows. So you'd have to make sure that that modern version of Windows is compatible with the app. If it's not, then there's another strategy, and that is to use nested virtualization. Now, nested virtualization is a VM in a VM. So you would have a modern virtual machine running on Azure. Then in that more modern VM, you would install the old operating system as a guest VM in the modern VM. And so you'd have something like Linux running maybe QEMU or KVM. And then that KVM VM would be running some old version of Windows like Server 2003 or Server 2008 or whatever it might be. And this is probably going to have a high degree of success, especially if your app requires an old version of Windows to run. So that would be a decent approach if you needed a more surefire approach. But the drawback of this one is you now have 2 operating systems to maintain. So there are some trade-offs for it, but it's probably going to be the most compatible option. Now, the 4th option in this more canonical approach would be a Windows container. Now, Windows containers don't have a UI, so you have to be able to install and configure the app using either the command line or using remote tools connected to a container to make that all work. But a Windows container can still run a lot of the same software that a Windows VM can run, so you'd have to finagle with that to make it work. Now, the less canonical approaches, or some of these edge cases, are ones that require a lot more trial and error because they're just not mainstream cases. Sometimes they can work. It just depends on the scenario. And sometimes they might not even work. It's very contextual based on the problem that you're trying to solve. The first one is to use Wine. Now, Wine is a compatibility layer for Windows applications running in Linux. And it tends to work better with older software. Newer software tends to struggle with Wine, but I've gotten some old apps that were written in like .NET 1 or even .NET 2 working in Wine without any issues. So it's an option. Another option is to use the Mono framework, which is an open source implementation of .NET. And it has a great deal of compatibility with .NET applications. So if you have a .NET application and you want to attempt to port it to Mono without changing any code, that might be a possibility. Then you could use something like Apache if it's a web app to host it, because there's plugins for Apache to run Mono ASP.NET applications using the Mono framework. However, that could be a challenge because of compatibility issues between the full version of .NET and this open source implementation. Another option would just be to use a more modern version of .NET. If you can do that with the app and you have the source code and you have the ability to upgrade it to a more modern version of .NET, that would certainly be a more viable option. And in that case, you could probably host it anywhere. You could put it in platform as a service, VM, container, it doesn't matter. It could be Linux or Windows if you could put it into a modern version of .NET. But again, that's very contextual based on the code base that you're using. And of course, the last option is to do the VM in the container, which is what I'm trying to show you how to do here. And this case is going to be very much like the nested virtualization, where you have a nested VM in a container. So instead of having a nested VM in a VM, you have a VM that's nested in a container in this case. And it's certainly an edge case, but it has a great deal of compatibility with old software because you're going to be running in a full operating system, except you're going to be using a container to host it instead of a virtual machine. So let's look at the architecture now that we've considered the scenarios. The architecture for this is pretty straightforward. You're going to have a hosting environment. And this could be any container running environment. So this could be a local Docker context. It could be Kubernetes of some kind. It could be some kind of platform as a service like Azure Container Instances. You could run this on Azure Web Apps for containers or even container apps. Doesn't really matter as long as you can run a container. All the magic happens in the container. Now the container is going to have a hypervisor installed in it, in this case, QEMU. Now, if you're not familiar with QEMU, it's basically a Linux hypervisor that you can actually run it on Windows too, but it has two options for running VMs. You can run them either in hardware-assisted virtualization or you can use binary translation. Hardware-assisted virtualization is a feature of most modern processors where it will basically allow you to take calls that are made to the CPU from within a VM and translate those into calls that the host operating system's CPU would understand, and then it goes the other way. And you get very native speeds out of virtual machines by using hardware-assisted virtualization. If you have to use binary translation, you're doing that all in software, so you take a big performance hit. Now, most VMs that are going to be running in the cloud of any kind are going to be using some kind of hardware-assisted virtualization. But given that this is in a container, you're not going to have that luxury. So you pretty much have to use binary translations. Now, there are ways to make KVM exposed to a container, and you could get hardware-assisted virtualization in a container, but it requires a more privileged access for the container, and that's not going to work in every scenario. However, you can certainly run any kind of virtual machine if you're using binary translation, because that's going to run in user mode, which is typically what you get with a container. And with that, you can basically create a VM that's going to run in the container regardless of how you are connected to the underlying CPU. And if you're doing this with binary translation and you're running an old operating system, you actually aren't going to see a whole lot of difference, because when an old operating system was written and is running on older hardware, that old hardware is going to be rather slow compared to modern hardware. So you're not going to feel a whole lot different than if it was running on that old server sitting in the closet than if you're running it in a VM in a container using some kind of binary translation on a modern CPU. And in some cases, it might even be better, because modern CPUs are light years beyond what they were even like 10 or 15 years ago if you were targeting something like Server 2008. So in any case, once you have your VM up, you want to store the actual virtual hard disk outside of the container in keeping with good container practices. And that's just in case the container gets blown away or moved to a different node, whatever it might be, you can still have your data around. So to do that, we're going to have some kind of external storage. Now, that external storage will have the VHD, and then we'll just mount that into the container as part of the container's file system. Now, if this is running in a local Docker context, that's simply just a path on the host VM or the host machine mounted into the container. If it was running in the cloud, you might use some kind of file service like Azure Files to do that. And so you could use Azure Files to host the VHD and then run it in something like container apps. And then container apps would just mount the file service into the container, and it would work just like it would in a local Docker context. Either way, you get the VHD on some kind of file system that's outside of the container, and you're able to read and write from it. So once you have all of this up and running, you're ready to go, and your VM should work just like this. And this is the way I would set it up, regardless of how I was going to do it, even if it's for dev work and doing it in a local context. Let's talk through this Dockerfile. This Dockerfile is pretty similar to the ones that I've been using for the other projects I did with DOSBox, with RetroArch, and Windows 98. This one instead is basically taking the same approach, but instead of installing things like DOSBox and RetroArch and using 86box, it's installing QEMU as the hypervisor here. So you can see that it's probably out here towards the end where I set it, somewhere in here. And this apt-get install, it's installing QEMU. And it configures a bunch of stuff as part of the stack to have the results stream back to a browser. So this allows me to interact with the virtual machine that I'm going to be installing using a graphical user interface. So I can interact with Windows 98, or I can interact with Windows 2008 if I'm using QEMU in the browser. So I have mouse and keyboard control without needing to install something like RDP or some junk like that. So this is going to install VirtualGL and TurboVNC, which is the VNC client, and then VirtualGL, of course, provides some acceleration there. NoVNC is the part that gives me access to the stream coming out of TurboVNC, but it streams it back to a browser, and it's using Rat Poison, which is basically a Chromeless window environment. But in any case, it's going to boot into LX Terminal because I'm going to boot to the terminal, but this will allow me to configure and start the virtual machines that I'm going to be running. In any case, and then it exposes it on port 80, and of course you can run that using port 80. I think some of these other services start on other ports, and it's using Supervisor D to start all of this stuff up in the container. So it's a pretty straightforward Docker file. And of course, if you want to study it and use it, it's linked in the video description down below. So I'm remoted into my box here, and I want to first build my Docker file here. So that's pretty straightforward. You can just do Docker build on the command line, and then you can do -t, call it whatever you want to, QEMU, and then just build it in the local box here. And mine's going to build, should be able to build pretty quickly because you're going to use some cache layers. But in any case, we'll come back when this is done. So let's talk about the run command for this for just a second. To run this, we're going to use Docker run. And I already have the command up right here. We're going to do Docker run, and then we're going to do a couple of port forwards. 8081 is going to go to port 8080, and that's the port I'm going to be interacting with this particular container, and ultimately the UI through a browser right here. That's going to be using NoVNC. And this right here is 8881 coming back to 8888. That's the port I'm going to be using for the ultimately for the app that I want to run. That's going to be running on this particular container in the VM. And then this is the volume that I want to mount right here. So root is getting mounted into the ISO folder on the actual image itself. So that's going to allow me to have the external storage that I want for my VHD, as well as for the ISO file to install. And then of course, QEMU is the name of the image that I just built. So if I run this, it should just install, start the container up, and everything should come up and run. And then I'm going to go ahead and pull up a browser and log into this guy. So I've got my browser open here, and I'm going to point it to the IP address, then port 8081, which is that port I created on my container for interacting with this through the browser. So I'm going to click on vnc.html and then log in with password 1 for the password. Of course, that's part of the Docker file, so you can definitely change that if you want. So I'm logged in as root here, and QEMU is installed. The first thing I need to do is create a disk image. So to do that, there's a utility for that on QEMU, and I'm going to use a command that I have staged already. I'm going to use a clipboard right here to paste in the command. So this gives me the ability to pass text between this container in the browser and also with NoVNC. So if I put it there, then I can right click here and hit paste, and now it's in the terminal. And this is running LX Terminal in X Windows context because I need this to be able to run graphical applications. So We'll make that possible in a minute, but you could also do this through Docker exec if you wanted to do it that way. So this will basically create a disk. It's not fully allocated at 10 gigabytes, but it's pretty straightforward. You're just telling it QEMU image create, and then you say -F format. That's a VPC, which is the format for a VHD. And then you say server 2008 VHD is the path for your virtual hard disk. In this case, it's in that ISOs folder, which I mounted from the host operating system. And then you tell it the size, 10 gigabytes, which is fine for server 2008. So if I CD to that ISOs folder, you can see that I have a couple other files here. I have another VHD and some other junk that I have around here. There's the VHD that I just created, and there's the ISO that I just that I'm going to be using to install this. So to start a virtual machine, it's actually really straightforward. So I'm going to use a different command for this, and it's already staged as well. You can see here that I'm pasting in the command here back into the clipboard, and I'm going to right click and paste the command into the terminal. And you can see that it's now using a different utility. QEMU system i386 is basically saying use x86 32-bit, and you tell what Pentium level. Your Pentium is basically using that instruction set, and it's got some extensions part of it that this can take advantage of. Tell it the amount of memory you want to use, so 2 gigabytes, and then point it to your hard disk. And then in this case, I'm going to be using that server 2008 that I just created. I have another one that I was using for my experimentation, and then I'm doing -cd-rom. That's pointing to my ISO file. Boot dash the drive, and then I need a NIC on this. So I'm telling it to use a user mode NIC. That's important because it's going to use a user mode NIC that allows me to basically keep everything in the container, so I don't have to mount any kind of privileged network administration tools into this. It's just all in the container. And then I'm going to tell it to use model E1000, which is the model of the NIC that I'm going to use, which is an older NIC that will work fine. So 1 gigabit NIC. And then this is saying forward port 8888 to port 80 in the inside of the virtual machine. So this is the port that the container is exposed. And then I port forwarded 8881 to that port. So it's a little bit confusing there, but you've got a couple layers of port forwarding going on here, but it gets the data back into the back end. So that's where I'm going to be running the application. In any case, so if you do this, this is going to start the virtual machine, and you can see that is now loading Windows files. And this will run you through all of the stuff that you need to do to run a Windows setup. So I'm not going to walk you through how to set up Windows. You can probably figure that out yourself, but it is now running the installer for Windows. And once that's done, you're ready to go, and you will have a Windows installed. So once you've installed the Windows operating system, you get this logon screen for server 2008. And so you can now use the Control-Alt-Delete button and log into this guy and punch in a password. So the mouse doesn't track perfectly with the host mouse, so you have to kind of deal with that. But in any case, the experience isn't too bad. So if you were just running a web app in this, you don't have to log in. This is if you want to do server administration on this particular box. Now, the server administration part is going to allow you to install things in a graphical environment. So if you wanted to install your app using this, you could download software. You can apply, installers using click-through wizards and things like that in this context. So it is a graphical user interface for Windows, so you can definitely use it this way. But you don't have to boot this in this fashion for this particular installation. So I've already set up to a IIS instance on this. So to show you what that looks like, I'm going to pull up localhost here. Just do an HTTP localhost, and it's running IIS 7, of course. If I was going to expose an app on this, I would expect to see this screen. So let's take a look at this. So I did port forward that other port 8888, and I think it did 8881, but this is the original one I built right here. I should see IIS 7 right there. So you can see that I'm seeing the same thing. So this is running IIS 7 in a virtual machine in a Docker container on a Linux host, in a Linux container on a Linux host, which is a lot of nested virtualization going on there, but it's kind of absurd that this is actually working as well as it actually does. So something that is a legitimate option for running old apps. So what are the caveats of doing this? There are at least two that I can think of, probably more if I sat down and think about it. The biggest one is going to be security. The difficulty with running old operating systems was like Server 2008, Server 2003, 2000, NT4, what have you, is that there's no longer support for those. And so if there's vulnerabilities in the operating system or any of the software, then you run the risk of being compromised. So to mitigate against that, there's a couple of things I would definitely do. I'd probably harden the container a little bit as much as I could to the degree possible. I would probably also put a WAF in front of this and let the WAF do SSL termination rather than let the IIS instance do some kind of SSL termination there, because you're going to get a much more modern version of TLS using a modern wrapper around this particular VM than letting the VM itself manage that. So you can take advantage of much more modern security practices and better encryption technology than what is available in some of these older operating systems that don't offer those. So you would definitely want to put the WAF in front of it, put the modern encryption in front of it, harden the environment as much as you can, and do what you can to mitigate against that. And of course, make sure all of the software inside of the operating system is patched as well as you can, and make sure it's up and running. So that's going to be a struggle in any case. Another thing that you have to figure out is licensing. And of course, licensing is always something that's a concern with server. So I don't know what the licensing implications of this are. This is a container, so it's running a VM. So there's licensing verbiage and the EULA for containers on Windows, but running a VM in a container, I don't know what that means. But in any case, this is just using MSDN subscription instance of Server 2008 that I downloaded the ISO for. So this is for dev purposes. I'm not going to run production apps in this, but in any case, it does work. It's very interesting to try it, but you'd have to figure out what the licensing implications of this are. But in case, just something to look at and consider as an alternative. Now, there are certainly things that you can do once you've kind of got this figured out and you want to productize it. If you wanted to go that route, you would have to change your Dockerfile to boot. And to do that, going back to that Dockerfile that we looked at a moment ago, if I was going to do this inside of my Dockerfile, the only thing that I would change in this case is I would put the QEMU command instead of executing lxterm. I would put the QEMU command right there to launch it. So basically, I would paste in that QEMU command that I had a minute ago over lxterm, and that way, whenever the Docker container boots, that will start up the virtual machine as well as part of the container boot process. So you just have to change that as part of your Docker, your file, and but remember where you're mounting in your VHD. Once you have that provisioned, you could just rebuild the Docker image using that new command, and then you would have a particular command to boot that particular VHD or something like that. But other than that, everything else is pretty much the same, and you would have the ability to log into it and administer it. And of course, you can disable that if you want to. You don't have that port open and just have the port for the app open or whatever. If you wanted to build the image using QEMU on Windows, you could do that and just use this to boot it or whatever you might want to try. There's a lot of options in terms of like getting the image ready, and once it is ready, you can use this as a way to just kind of host that image in a VM in the container. So if you like this, drop me a comment in the comment section down below. Let me know what you think. I'll definitely put this particular Docker file on GitHub, and you can download that. It'll be in the video description too. And I'll have the commands in the video description as well as in the README for the Docker file, so you can check that out as well. So as always, like and subscribe, and share this with your friends. Drop me a comment. If you're interested in this, I'd love to see what you're trying to do with this. If you think I'm crazy, tell me I'm crazy. If you think that this is cool, tell me I'm cool. If you like this video, of course, let me know what you want to see. I'm always up for a challenge of Dockerizing stuff. So if there's something that's absurd that you want to see a Dockerize, I would definitely attempt it. Maybe I've been working on the Windows XP version, and definitely that's pretty easy. But this is certainly something I've been working on to try to get it to work, and it seems to work fairly well. So again, let me know what you think, and look forward to seeing you on future videos.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @theonemule. And as always, thanks for watching.